Good morning, students. Today we are going to deal with the topic that is metals and non-metals. The next topic is extraction of metals from their ores. Already we have discussed about this topic, that is steps involved for the extraction of metals. Today we will see along with the reactions. Highly reactive metals, medium reactive metals, least reactive metals. Metals with the low activity series, metals with the medium reactivity series, metal with the high reactivity series. You see the different points here. You see the different process here. The process already we have discussed in the last week also. For sulfide it is roasting. For sulfide and carbonate, it is calcination, and for the highly reactive elements, it is electrolytic reduction is there. Process is there or electrolysis. Okay, we start with the step by step. The first point is about the metals of low reactivity series. Yes, extraction of metals of low activity series. Low activity series, usually the copper and mercury comes into this. The ore of copper and the ore of mercury. For example, start with the ore of mercury. You know about the copper. Copper is available both in free state as well as in combined state. First, we'll start with the mercury, then we'll go with the copper. Mercury. Mercury is available as mercury sulfide. I repeat, mercury is available as mercury sulfide in nature. It is an ore of mercury as cinnabar. Usually, this cinnabar or the ores of this cinnabar, one is mercury sulfide, that is cinnabar. One more and take it. It is copper 1 oxide, Cu2s. Copper 1 sulfide, Cu2s. It is also called as copper glance. Yes, cinnabar and copper glance. These are the two chemicals of low activity series. Cinnabar starts with the cinnabar. Usually sulfur, sulfide and the sulfide. Mercury sulfide and copper 1 sulfide. Both when they react with the oxygen, because these are sulfide ores. Roasting is the process. Heating in presence of excess air. Heating in presence of excess air. For example, as mercury sulfide is reacting in presence of oxygen, in presence of oxygen to form mercury oxide. Mercury oxide and sulfur dioxide. Mercury oxide and sulfur dioxide, then we have to balance the equation. Okay, 2HGS plus 3O2 will form HGO. 2HGO and 2SO2. Okay, now mercury oxide is available. Mercury oxide is available and sulfur dioxide is liberated. Mercury oxide is available. This mercury oxide, if you heat this mercury oxide, you'll get it mercury and oxygen. Yes, mercury and oxygen. So mercury is available, this mercury, but it will not be pure, it will be an impure mercury. Okay, this is about the cinnabar, how to extract mercury from its ore, that is cinnabar. Next, second will be of copper glands. Copper glands, it is also called as copper 1 sulfide. Why it is 1? 1 means its valency is 1. Valence of copper is 1 and valence of sulfur is 2. So it is copper 1 sulfide, also called as copper glands. Sulfide is once again reacts with excess amount of oxygen, roasting process. Copper oxide and sulfur dioxide. Once again, we have got this copper oxide. This copper oxide reacts with the copper glass once again to form copper and sulfur dioxide. Okay, copper is available. Once again, this copper is impure copper. This copper is impure copper. Yes, this copper, or if you take it as the mercury Hg, both will be impure. Those will be purified with the electrolytic refining process. Electrolytic refining process. We'll discuss about this electrolytic refining process in the last session of this topic. Okay, this is about the mercury. It is about mercury sulfide cinnabar and copper from copper glands. Copper oxide will once again react with the copper sulfide to form copper and sulfur dioxide. Copper is, but this will not be copper. It is called as impure copper. Okay, now next is extraction of metals of medium activity series. Mercury and copper are least reactive elements or least active metals, and now is a medium reactive element. Is extraction of metals of medium activities series. Medium activity series, usually you'll get here zinc, you'll get here aluminium, you'll get here aluminium also. Iron is, aluminium is highly reactive. Aluminium is used as a reducing material here, especially zinc sulfide or zinc carbonate. Here the sulfide ore is there, here the carbonate ore is there. Yes, sulfide ore and carbonate ore, because zinc is a medium reactive element. When the iron is there, manganese is there. These all are the elements which comes under this medium activity series. Zinc, manganese, as well as iron is there. Okay, we start with the zinc sulfide. Zinc sulfide, sulfide is there. Sulfide means its roasting will be there. And carbonate is there. The carbonate is there. It is considered as the process is calcination. Yes, carbonate is there, calcination. What is roasting? I told earlier only, heating in the excess amount of oxygen in presence excess amount of oxygen. Heating in excess amount of oxygen. Heating, what is this calcination? Heating in absence of oxygen. Zinc carbonate, carbonate material is there. The process comes the calcination. Here we have to heat this material in the absence of oxygen. Here for this roasting, we have to heat in the excess amount of oxygen. Once again, the zinc sulfide looks like the same the sulfide ore of those chemicals. Now start with the process. Okay. First start with the zinc sulfide. Zinc sulfide, it reacts with the oxygen to form zinc oxide and sulfur dioxide. Zinc oxide and sulfur dioxide. Zinc oxide is there and sulfur dioxide is there. Okay. Now we have to balance the equation. 2ZnS, 2ZnO, 3O, 2SO2. So 2. Okay. We have got the zinc oxide. Still, it has been oxidized, reduced to the zinc sulfide to the zinc oxide. Now we have to extract this material. We'll reduce this material from zinc oxide to zinc. Later on, we'll take now directly zinc carbonate. Zinc carbonate. Zinc carbonate, directly you have to heat it. Okay. Now we have to take it as zinc carbonate. If you heat directly, because carbonate is there, you have to go for the calcination, heating in absence of oxygen, roasting was there in the presence of excess oxygen. So here zinc carbonate, heating in the absence of zinc oxide and carbon dioxide. See here, zinc oxide is available once again. Zinc oxide, both are zinc oxide only. Here what happens? Both are zinc oxide. Now, this two, zinc oxide will be reduced to the zinc with the help of a reducing material that is called as carbon. Carbon, which is a carbon, that is coke. Maybe I've studied this topic in the class 8, coke. This is an allotropic form of carbon. Actually, we are having four atomic form of carbon. That is, one is coke, coal, charcoal, and soot. Coke, coal, charcoal, and soot. These are the four allotropic forms which comes under the amorphous forms. Amorphous form of carbon. Crystalline form are graphite, diamond, and fullerene. These are amorphous form. In this, we are taking coke as an reducing agent here. Coke as a reducing agent to form zinc oxide, zinc plus carbon monoxide. As zinc is separated because both are zinc oxide only, so we have got the zinc. But some impurities will be there. Why they take the coke only compared to they not take aluminum here? They can take the aluminum also, but they'll take coke only because coke will be cheaply available compared to the other elements. Aluminum will take only if the metal is more costlier than the aluminum. Then only aluminum is considered for the reducing agent. Otherwise, it will not considered. Here, coke is very cheaply available, but this coke, adding of this coke will mix some impurities in the metal. It will be once again the same process I told it earlier only for the low reactivity series, that is electrolytic refining is there. Even the available apart from electrolytic refining. Okay, these are about the medium activity series. Zinc sulfide or zinc carbonate. If it is sulfide, it will go for roasting, and if it is carbonate, it will go for the calcination. Roasting, you have to heat in the excess amount of oxygen. It is 3O2 is there, and carbonate, it is heat in the absence of oxygen, and directly heating is going on. Zinc sulfide with the oxygen to form zinc oxide and sulfur dioxide, or zinc carbonate is heating zinc oxide and carbon dioxide. The first process is roasting. It's roasting, and second one is yes, it's calcination. Yes, calcination in the absence of oxygen, roasting in the presence of excess amount of oxygen, not normal amount of oxygen, excess amount of oxygen. Okay, at last both are available. Both you have got the same chemical, that is zinc oxide and zinc oxide. This zinc oxide, if you reduce, it will form zinc and carbon monoxide. Zinc is available, but due to the addition of carbon, it has become bit impurities. It will be purified later on. Okay, it's a different process. It is about the zinc sulfide and zinc carbonate with the help of carbon. Not only the carbon is considered as a reducing agent. Apart from carbon, there are multiple chemicals. Apart from carbon, we are having an aluminum also. Just now I told about the aluminum. Apart from aluminum, carbon aluminum, we are having the sodium. These are the different chemicals which are used as reducing agent to reduce this chemical. Okay, for the reduction process to get the metal. Okay, we'll see now with the aluminum how it is possible. Just now we are seeing the carbon because carbon is used here to get the reaction or to extract the metal. Now we'll see the next, that is aluminum. Yes, aluminum for the manganese. Aluminum is also called as aluminothermy, or it is also called as thermite process. Thermite process is also used for the iron also. It is also used for the manganese also. First we'll see with the manganese, next we'll go with the aluminum. That is iron. Manganese. Manganese oxide is reacting with the aluminum to form manganese and aluminum oxide. Okay, here to balance it, 4Al, 3Mn, 3Mn. This aluminum is used, it is also called as aluminothermy. Or best word is thermite reaction. Thermite reaction. Why it is called as thermite reaction? Huge amount of heat is liberated. So it is considered as a thermite reaction. Maybe you are seeing that spark when the metals are joining. Maybe you have seen in the automobile store, bike repair store, or those where the metals are joined, the cracked metals are joined. The process is thermite reaction. The iron is joined, but huge amount of heat is liberated. The spark will be there for continuously. That is nothing but thermite reaction. For example, is reacting iron oxide. Iron oxide is reacting with the aluminium to form aluminium oxide plus iron. Okay, Fe2O3, 2Al, and 2Fe. Yes, here huge amount of heat is available. Huge amount of heat and spark will be available. That is heat and light that is used for the joining of metals or machinery parts or joining of those railway tracks. They will join it. Those all are this process of thermite reaction only. Okay, it is these are the uses or applications of this thermite reaction. Joining of railway tracks or the machines, identifying that cracking of machine parts and joining them, those all will comes under this process. That is thermite reaction. And here manganese oxide is here and here. Iron oxide and manganese oxide. Yes, manganese is a medium reactive element, even the iron is a medium reactive element. Yes, these metals, when they form the oxides, no, it becomes manganese and or iron with the process of with the help of aluminium. That is called as thermite reaction or aluminothermy. Okay, we'll go for the highly reactive elements now. Yes, next is about the highly reactive elements like sodium, extraction of metals of high activity series. High activity series will be there. Yes, extraction of metals of high activity series. High activity like sodium, potassium, aluminium, or calcium. Yes, and here the process is there electrolytic reduction. Electrolytic reduction. When you pass the current, metal will move towards the cathode and non will move towards the anode. Okay, that is start with the sodium chloride. Yes, sodium chloride. Sodium chloride. Sodium chloride is the element. How it is formed with the help of sodium and chlorine. And very strong bond will be there. For this, the passing of electricity is important. It is also called as electrolytic reduction. Here, carbon is not used as reducing agent. And not used as reducing agent because if you go with the carbon, no, these all metals are having more affinity towards the oxygen, maybe sodium, potassium, aluminium, or calcium. Sodium, potassium, aluminum, or calcium. These are having more affinity towards the oxygen, not so easy to break. So they will use the will not use the carbon. They will go for the electrolytic reduction, where sodium ion will become get the reduce the electron, get the electron to form sodium or chlorine. Ion uses the electron to form chloride. Chloride ion reduces the electron to form chlorine. S 2NaCl actually 2NaCl will use 2Na plus Cl2. Sodium and chlorine will be separated. The process is called as electrolytic reduction. Yes, this is about the extraction of metals of high activity series. Okay, the last process of this topic is refining of metals. Refining of metals. How the metals are refined? Metals are available, those are impure metals, but these metals have to be refined. The process is there. How these metals are refined? With the help of the chemicals, the movement of these electrons. That is, it is also called as electrolytic refining. The process is electrolytic refining, where it is having the anode as well as cathode, the supply of battery, a tank will be there, and then electrolyte. Electrolyte is nothing but the solution of the same metal. Let's show the various process is electrolytic refining. Electrolytic. Okay, refining of metals. Zinc is there, lead is there, mercury is there, copper is there, tin is there, tin is there, sil- silver is there, gold is there. These all are the metals can be refined with the help of only this copper, refining with the help of electrolytic process, that is electrolytic refining. Electrolytic reduction was there for the highly reactive elements, that is electrolytic refining, because these metals are impure, metals are available, these has to be refined or make it as pure here. Electrolytes are also available. Which electrolyte is the solution of same metal? Solution of same metal. For example, if you are with the gold, the copper is going to be refined or make it as pure, but to use the copper sulfate solution. Copper to the copper sulfate solution. Yes, apart from that, a tank, one more, there should be a battery, anode and cathode tubes. Okay, they pass the electricity and in the solution, that is electrolyte. At last, the dissolved materials are available needed to refine metal. At last, the pure metal is available. The pure metal is available. So we use dissolved materials and we pass the electricity. Pure metal is available. Okay, we'll see it. The process of electrolytic refining of copper. This electrolytic refining of a tank or a container, tank or a container with the cathode and anode. Okay, anode, cathode, there is the battery or electrical supply. Now we are refining the copper. It should be okay. Here anode and cathode is there. It's positive to negative. Okay. Here we supply the electricity for this chemical. Here it is having the copper plate. This anode is having copper plate. Cathode will get the pure copper. Okay. What happens when the electricity is supplied? The chemical which is present on this anode will move towards this chemical. To dissociate all the electrons, Cu2 plus will move towards the this copper sulfate solution. This is copper sulfate solution. Okay, so copper sulfate solution. We are refining the copper from copper sulfate solution. That is electrolytic refining of copper. Copper is available on the anode part. This cathode is there. The supply the electricity. The copper present on this, it will move towards the this copper sulfate solution, and the same quantity of pure copper will move towards the anode. Copper will move towards the here in the copper sulfate solution, and the same quantity of the copper will move towards the cathode. The anode start to become thinner and thinner because all the copper which is deposited on the anode will move towards the solution, and the pure copper will move towards the cathode. This will deposit towards the cathode solution, and the pure copper is available in this part. Now, what happens when the metal is moved towards this? Automatically, lot of impurities will be there. Lot of impurities will be there. They will come, and it is here now. Slowly, they'll come. They'll disperse in this chemical. They will join here. It is called as anode mud. Anode mud. Yes, here we are getting pure copper. Here it was impure copper was there. Impure copper will move towards solution, and the pure copper will move towards the cathode. It will become thinner as all the pure copper will deposit on the cathode part. It is about the electrolytic refining. Here all the waste materials are there, but anode mud even it will be having the some of the most valuable chemicals also present on it. Maybe on copper, maybe silver or gold. Those will also available. That will be separated later on. Those are extracted or those are refined or those are cleared later on, that chemical. So this is a process of electrolytic refining. There's nothing is there. I'll repeat once again. A container is having the chemical that is copper sulfide solution plus a little bit amount of sulfuric acid. A small quantity of sulfuric acid is also present in it. When you pass the electricity, the chemical moves all the impure metal which was deposited on the anode part will move towards the solution, and the same quantity of the pure copper will move towards the cathode. The remaining material, that is waste material, will settle at the down. Here we are having two processes. The first is metal is purified or refined by through this electrolytic refining. We are getting metal is purified, and second one is the gangue. Some of the rare elements, rare metals or noble elements like silver and gold can be available, which are separated from this mud. Okay, precious metals, precious like gold or silver, gold or silver which are attached with the copper, those are separated and those are available. So that is helpful for the economy also. So It is all about the electrolytic refining of copper. Okay. Now, the last topic is remained that is called as corrosion and alloying. Alloying is also a process which comes under the corrosion. So we'll discuss these all topics in our next class. Along with the, we'll go for the question papers which are available in the CBS website. CBS website has given the uploaded some question papers. So we'll discuss those all questions in our next class. Okay. Yes, this is about the refining of metals. Last part is about the corrosion. Tomorrow we'll discuss about this topic. Okay. Thank you to one and all.